So this is the part 3, the last part of lecture 6 under the topic functions. Up to this point, you have learned the basics about functions. You know the syntax of a function, you know how to pass arguments, you know that the function arguments are passed by reference to the objects. From now on, the next few slides in this part, we will learn more about function parameters or arguments. And then we will talk about the return statement, and then finally we will be talking about scoping of variables, global versus local. When we talk about function arguments in Python, we are mainly talking about 4 different types of function arguments. Type 1 required arguments, type 2 keyword arguments, type 3 default arguments, and type 4 variable length arguments. In the next few slides, let's look at what each of these are. The first type of arguments we are going to look at is required arguments. So this is the most commonly used and the one you are already familiar with, right, from the previous examples that we have discussed. So the required arguments are passed to a function in the exact same order which the function is defined, right? So in a function, if you have argument 1, argument 2, argument 3, then when you call the function, you have to pass in the exact same order, right? Argument 1, argument 2, argument 3. So the number of arguments in the function call should match exactly the number of arguments in the function definition, otherwise it will throw an error. So to call this print me function that you saw earlier, right, we have seen this function a few times. It just takes a string, so we have shown it in the slide. Print me takes a string, one argument, right, and it just prints it. So when you are calling this function, you have to pass exactly one argument, right, this string, otherwise it will give an error. Let's see what happens when we call a function, in this case the print me function, without the expected argument, right? So as we know, print me is defined with one argument, str, and so it's defined just like before. Let's call it without any argument. So it will give an error, as we mentioned earlier. So it will say line 1, okay, type error, print me missing one required positional argument. Argument name is str, right? So the required arguments, you have to provide them. The number of arguments should match. So here it's 1, cannot be 0, and if there are multiple arguments, the order has to match as well. The second type of arguments we are looking at is keyword arguments. So when you call a function with keyword arguments, we specify what argument we are passing with a keyword. This keyword is the same keyword that's used in the function definition for a particular argument, right? So if you use keyword arguments when you call a function, you don't have to worry about the order, because the arguments are mapped using the keywords that you use, right? It just has to match whatever the keyword that you define the function with. So in this case, you are allowed to skip arguments or place arguments out of the order, right? It doesn't have to match the order that the function is defined. Let's look at an example of using keyword argument types. So we have a Python program, a very small one as before, slightly modified print function. Here we have print info takes two arguments, name and age. Basically prints the name, says name and then prints the name, and then says age and print the age that it takes from this argument. So let's see if we can call this print info function using keyword arguments. So look here. Although age is defined second, we can call it first. Name is defined first, but we can call it second. We can only do it because we are calling the function with keyword arguments. So we are saying age equals 20. So when you say what argument we are calling, it doesn't matter if it is defined first or second or third or fourth, right? Because the mapping to the argument to the value passed is done using the keyword, right? So that's the reason we can interchange or just go out of order, right, without matching the order of the defined arguments. And it's successfully called because we see the output name equals Kumari and age 20, right? So that's how you call a function with keyword arguments. Try to look at the difference between this and the previous one. The next type of arguments we are going to look at is default arguments. So when you define a function, you can have a default value for a particular argument or some arguments. So if that's the case, when you call that function, you can call it without providing a particular value to that argument for which you have the default value already defined. Let's look at an example of how to use default arguments. So we have a familiar function again, right? Print info. That's a simple program with that. So in print info, we have two arguments as before, but here in the second argument, age, we have provided the default value, right? This is simply how we define a function for some argument like this age. We have provided the default value, right? So as before, we just print the name, say name and print name. The next line say age and print age. So in the Python, the main Python program, we are calling it twice, calling this print info function twice. First time, this should look familiar. We are passing some keyword arguments at age equals 20, name equals Kumari. So in this case, these two first lines, right, this line and this line are printed from this call to that function. Age is 20, right? So irrespective of the order, since we are passing with keywords, okay, it's taken correctly, name and age. It's printed Kumari and age is 20. Next time we call it just with one argument, name equals Kumari. We don't provide anything for age. So let's see what happens. It goes here. Name we have given Kumari and age we have not provided the value when we call the function, but there's a default value. That's why when you call it the second time with just one argument, just the name, still we get the age. So first, there is no error, right? It doesn't complain that the arguments are less than expected because we have already provided a default value for age, and age is printed as 25, right? So that's how you use a default argument in your Python functions. Now let's look at variable length arguments. So this is quite different from the previous ones because variable length arguments, as the name suggests, allows you to call a function with more arguments than the number of arguments in the function definition. So these arguments are called variable length because there's a placeholder argument. So like here, var args tuple that holds a larger number of, so more than one argument in here, right? But we just define this one argument that holds this variable length arguments. The unique thing to see, or how you differentiate this from the other arguments that we have seen before, is this leading asterisk. Right? This asterisk indicates that this is the argument that will eventually hold the variable length arguments. If no additional arguments are specified during the function call, you can just leave it out. You don't have to mention anything. Another thing to note is that in the function definition, first you have the formal arguments, like the required arguments and the keyword based arguments, and then only you have these variable length arguments. So this will be clearer once we look at an example in the next slide. So this is the example for variable length arguments. We have here a small Python program, a bit different from before. So we still have a function with the name printinfo, but it's a bit different. So we have one argument, a required argument, and then we have a variable length argument. This asterisk var tuple. Inside the function, you can see first we print the first argument. Then we use this for loop to iterate through this var tuple variable length list of arguments. Right? So var tuple iterates through this var tuple variable length argument and prints each of those in this case. Right? And now we can call this function in this program. So we first call it with just one argument. If it is just one argument, it will go into this. Right? That's why we have this output. Output is 10. Right? You call printinfo 10. And if this is passed, and this gets passed, and it's printed like here. Output is 10. So var in var tuple does not have anything, so it's none here. That's why we don't have anything else printed. Second time we call it, we have 70 as arg1, and then we have 60 and 50. They correspond to this variable length argument. Right? These two go in var tuple. That's why when you call that function printinfo, first the first argument arg1 is printed as required here, and then it iterates through the var tuple. So 60 and 50, you can have them here, and then first 60 is printed, and then 50 is printed. Right? That's what we have, 70, 60, 50. So that's how you can use a variable length argument in your Python program when you call a function.
So here we have the same function that we had in the previous example, and so we have the definition of a printinfo function with one formal argument and a variable length argument, and inside this I print the formal fixed argument, and then I'll iterate through the variable length argument and then print the values inside there as well. So let's see what happens when we execute this program. Right, so as usual, the printinfo function gets a placeholder in the global memory pointing to the object that is created for this function, and then when I call this function first without just any values assigned to the variable length argument, but just one value for the argument 1, which is the formal argument there, you can see that an empty tuple is pointed to the var tuple. Right, so let's see what happens when we execute this. Right, so prints output is, and then print the value that is 10, and then because the var tuple is empty, does not go inside, and then we return back to the main program. Right, so next let's see what happens when we call the same function with 3 arguments. So in this case the first argument will be assigned to the arg1 variable, arg1 parameter, and the other values will be assigned to the var tuple. Right, so let's see what happens. You can see that arg1 is 70, but var tuple has a tuple created with 60 and 50 as values, and that is pointed, or that is referenced as the var tuple argument in the function definition. Right, so let's see what happens inside print output is, and then print the argument 1, which is 70, and then we iterate through the tuple, right. So the first value is 60, which is printed, and then we go back. The second value is 50, it is printed, and then we exit from the loop and return to the main program, and that concludes the execution of this program. So this is how variable length arguments work in Python.
That was all about arguments to functions, the first line of a function, right? Function definition. The last line typically is a return statement. That's optional. You don't need to have a return statement, right? If you don't have a return statement, it's equivalent to having a return none, right? Otherwise, if you want to return a value when you exit a function to the calling function, then you could use the return statement. So typically the statement return exits the function, and when exiting, optionally you could pass a certain result to the calling function. That's the idea of a return statement. So you can also pass more than one value or one object or one argument using a return statement. That would be written as a tuple. So in the receiving end, so the calling function, inside the calling function, you have to have a variable that will be eventually treated as a tuple in the case where you are returning more than one variable or one argument. Another way to return more than one argument is just by making a list and returning a list. Then on the receiving side, yeah, that variable holding that value, return value, is a list. Let's look at an example of how to use a return statement and then get that value and do something with it in a very small Python program. So here we have a function called sum, right? It takes two arguments, and so we can see it adds up these two arguments into a value called total. Then it prints the total inside the function, says inside the function this is the total, and then it returns this total. That's the function definition. Here we see how it's called. So we call the function sum, passing the two values arg1, arg2, 10 and 20, and then with the equal sign we assign the return value of this function into this variable total, right? So we call the function, we use the assignment operator, and then we assign the return value to total. So whatever value we have here after calling this function goes into this variable, and then here we print that value outside the function total. So if we pass 10 and 20, yeah, 10 plus 20 equals 30. So inside the function it says inside the function 30, that's this line, and then it's assigning value 30 to total, and then when we say print outside the function total, it says outside the function 30, right? So that's how you use the return statement. Let's dig into the details of this using the code visualization using Python tutor.
So here we have the same function inside Python tutor. Let's see what happens when we execute it. So you have the sum function which takes in two arguments and then adds them up and then print it inside the function and then returns the total value. Right. So first, as usual, the sum function gets a placeholder in the global memory which points to the object of the function, and then when we call the sum function, the argument 1 becomes 10, argument 2 becomes 20, and then we go inside the function. Right. So inside the function, local variable is called total is created, which gets assigned the value 30, and the value 30 gets printed inside the function, and then it is returned back to the global the main program that was calling this. So the return value is 30. So this return value gets assigned to this variable total, and then it becomes 30, and then when you print it, that gets printed. So this is how returning values works in Python.
Let's talk about scopes of variables in Python. You might have encountered this issue where some variables are not accessible from some parts of the program, right? So where you can access the variable depends on where you have defined the variable. So that is the scope of the variable. Basically, the scope of a variable determines the portion or the part of the program where you can access that particular variable. So there are several ways of categorizing it. One main way of looking at it is, so we have two basic scopes. One, the global scope, global variables, and then the local scope, local variables. Let's look at global and local variables scopes in more detail. So when a variable is defined inside a function body, right, according to the indentation rules, within the function body, that variable is a local variable. They have a local scope. A variable defined outside a function is a global variable and they have a global scope. However, even inside a function, you could write to a global variable. Then you have to use a keyword global to declare that you are writing to a global variable. Typically, the general rule is any name that is assigned anywhere within a function, it's a local variable, unless you use this global keyword to say, okay, this is a global variable, right? So typically, always know that a variable defined within a function has a local scope within that function. If a function is only reading from a name and if the name doesn't exist locally, it will try to look up the name in any containing scopes, for example, the global scope. Bear in mind, the global keyword that you can use within a function to assign to a global variable or to define a global variable has to be used with care, right? Because it will usually give rise to some unexpected behaviors, especially when the program is developed by multiple people or even by the same person, right? So there are some style guides to define global variables usually at the top of the program, right? So try to avoid using this global keyword to define or modify global keywords within a function. Right? That's not good practice. So to summarize what we have learned so far about global and local scopes, local variables can be accessed only inside the function in which they are declared. That's why they're said to have a local scope. Global variables, on the other hand, can be accessed throughout the program, right, by all functions. Right? You can access them from anywhere in the function, anywhere in the program. So when you call a function, the variables declared inside it are brought into scope. Let's look at a coding example where we see global scopes and local scopes of variables. So in this small program, we have here a global variable, right? And then we have a function sum, arg1, arg2. Inside that, we have this variable named total that takes the sum of these two arguments. So notice that here total is a local variable that's local to this function sum. Since we do not have the global keyword before it, it does not update this global variable, right? It's in its own scope a variable within the function which is named sum, and it returns the total. When you call this function named sum with two arguments 10 and 20, it goes in 10 and 20 are here, so total gets assigned 10 plus 20, which is 30, and it prints inside the function local total, right? Local total, this one is obviously 30. It returns a value, but the way we have called it, there's nothing to capture that return value, right? So it's not saved, it's stored in any variable. In the next line, we print outside the function global total. Global total is this. We print that, and it says 0 because we have defined it to be 0. So notice that this variable total has nothing to do with this global variable, right? This is a local variable, this is the global variable, and modifying this local variable has no effect on the global variable. Please proceed to the Python tutor code visualization here for you to understand more, like to visualize what exactly takes place in memory when you run this program and how the global scope versus local scope behaves. Now let's look at a modified version of the previous example. So here it's almost the same, except in this line we have global total, right? So previously we did not have this line. So this is the global keyword that we mentioned earlier to define this total, a variable named total, to be the same as the one that's already defined in the global scope, right? So without this global keyword, this would have been a local variable, but now this is connected to the global variable total. Right, now what will happen? So inside the function it's still 30, right? If you pass, so okay, we pass 10, 20 for this function sum, right? So it's called 10 plus 20 is 30, so total gets 30. Inside the function local total, here is 30, so it prints 30. However, globally it was defined 0, but we write to the global variable here. So what will be this? Outside the function global total, what's the value? So it should be 30. You can try it yourself, either using this link to the code visualization or in idle. The argument should be clear by now because we are defining this total to be this global variable. That variable is modified, although it's assigned 0 at the beginning. This part of the function modifies it. Therefore, when it's printed, the global variable named total, that has the value updated here. So it should be 30. Please try it out and see. Let's look at a bit more advanced scenario of scoping of variables beyond just global versus local scoping. This is referred to as the LEGB rule of Python. So we have now 4 scopes: local, enclosing, global, and built-in. So as you might have guessed, local has the smallest scope, and then enclosing is a bit larger, global is larger, and built-in is the largest. So here is a small coding example that illustrates all 4 of these scopes in 4 different variables. So import math. This is available in your Python runtime, very important and useful library for mathematical operations. Then we define this z global variable. Then we start the definition of this function example. Inside it we define x, a variable local to example, but it's enclosed into the next inner function, right? We have def example inner. That's the example inner is nested inside the example function. So in the example inner function we have a variable y, a string saying inner function, right? So understand y is from the local scope of this function, x is in the enclosed scope of this function, right? It's just outside, but it's not global. Then z is from the global scope, right? So if you go up to this line, this can print x, y, z, and maths.py. This is a built-in variable. It has the highest scope built in, right? So at this point, yeah, x is already defined in the enclosing scope, y is defined locally, z is global, math.py is built in, right? So it has access to all four, and there will be no problems. However, if you go just outside, so you go beyond the scope of this function, you can print x because x is in the local scope of that example function in which we are typing print x. However, from this point, y is not accessible because y is in the inner function, right? So it's not visible to the outer function. And x is not available anymore once you step outside the example function because x is defined locally for example function. However, yeah, z and math.py are available outside these two functions because z is a global variable and math.py is a built-in variable. Right, now it's time to summarize what we have learned in this lecture 6, functions. So functions are blocks of organized reusable code. Each function is used to perform a single related action. Function name should be suggestive of that particular action. Function arguments, right? We learned about 4 different kinds of function arguments: required arguments, keyword arguments, default arguments, and variable length arguments. Then we discussed how parsing of these arguments is done with functions, right? We pass arguments by object reference. Then we talked about the exit statements, right? How to exit a function by returning a value to the calling function. And this exit statement or the return statement is optional, right? So returning none is an option, or just dropping the return statement at all is the same. However, if you want a result to be sent to the calling function, yes, by all means use the return statement. Finally, we talked about scoping, right? We first talked about global versus local scopes, and then we looked at something a bit more advanced with the LEGB, right? Local, enclosing, global, and built-in scopes. We are ending the lecture with a couple of exercises for you, right? So please go through the slides. So this slide and the next slide, we have given you an exercise for you to try out, right? You can go to the Python tutor code visualizer also to have a look and understand in detail how it works, right? So this is the second exercise. Try it out. Use the code visualizer also to understand what exactly goes on.